Hi ho, Kermit the Frog here. It's the Learning Show! It's time to play the music. It's time to light the lights. It's time to meet the math man on another day of class. It's time to open Chromebooks. It's time to get it right. It's time to get things started.
Why don't we get things started?
It's time to get things started on the most sensational, inspirational, celebrational, math sensational. This is what we call the Learning Show. Happy Friday, everybody. I bet you thought for a moment that I actually got turned into a frog. But never fear, that did not happen. I'm here, and so we're glad you're here. And you know, I've never seen a frog play the piano before. Now, I've seen a cow play the piano, and she was quite a musician. But I thought, you know, if a frog's going to play the piano, he's probably just going to croak. But we're glad Kermit was able to help out this morning. And some of you, you need to be getting me your assignments. I don't know why you're not giving me your assignments. What'd you say? Kermit the Frog told you not to turn in your homework? I can't believe that. What'd he tell you? He said, rip it, rip it, rip it. No, he did not say rip your homework. He's a frog. He said ribbit, ribbit, ribbit. And so get the homework turned in, tape it back together. You know, I need your work, and so I also need your attendance. So make sure, you can pause this video right now, but make sure you fill out the attendance form. It's Friday, May 8th, and make sure you filled it out for the whole week. And so we won't be counting you absent, so get that in. And remember that Sunday is Mother's Day. You can't have any excuse, oh, we've been home, I forgot. And so make sure you have a special plan to do something special for Mom on Sunday. And so you think about that too. You still got a day or so, and get the attendance taken, and we'll be ready to start. Okay. And so in geometry, we're going to talk about midpoints. We've been talking about those for several years, but we're going to apply the concept to our analytical geometry. And so I'm only assigning tonight page 546, 14 to 21 and 24, and those are the harder ones where we're applying. I skipped all the just find the midpoint or find the distance, things we did in pre-algebra and algebra. But it is Friday, so make sure you get Khan Academy done. Some of you forgot, and we know who you are, and so don't always play catch-up. Try to get those done. And then the logic problems, it's Friday, so let's get those in. And don't wait till Sunday night at midnight. And we know who you are who do that. And so try to get it done. Make hay while the sun shines. And so try to get everything done. And so, but we're going to apply the concept of midpoint to our analytical geometry. And we're going to find the lengths of three medians. This is notes number 124. 1 doubles 2, 2 doubles 4. Our notes are a geometric sequence. And so doubling. But we want to flatten the curve, so we don't want those exponential growths. Graphs, not growths. Growth, growth, growth. And so, find the length of the three medians of triangle ABC with these points. Now, what are a median of a triangle? Well, let's graph this thing. I'm going to move myself. I don't know. Is there room for me? Point A is 0, 4. So if we remember that, I'll put myself right here. Maybe make myself a little bit smaller, as long as I don't turn into a frog. And so we have point A at 0, 4. We're going to put that dot right here and call it A. We got B at 6, 0. Well, my graph isn't even big enough for B. And we got C at 6, 4. Mr. Nyson, why did you not make the graph big enough? Well, we could go by 2's, but nobody wants to do that. And so we're going to connect these. We'll go A to C, B to A, and right here. Whoa, you stay there. And we got our triangle. It's a nice triangle. I really should have made my graph bigger. But where are the medians of the triangle? Where are the medians of a triangle? You know, sometimes you get confused. You know so much, and it's like, wait, there's medians of a trapezoid, there's medians of a triangle. Different shapes can have medians, and I'm getting confused. But you know, every median has to do with the midpoints. And so we need these midpoints. But then it's like, what do we do? Do we connect them? How do we connect them? And so, like, remember, like, when we were talking about, is this a median where we connect the midpoints? Are these medians? Or do we connect the midpoints like this to the opposite ones? Or maybe all these are me. I'm so confused. It's been a while. And so the reason you're confused, if someone is confused, there's usually a reason for it. And it's not just old age. So leave me alone. And so when we use the term median in a trapezoid, we connect the midpoints to the opposite sides. That's why some people refuse to use the word median when it comes to a trapezoid, because it confuses people. So they'll say that's called the mid-segment or something. That's probably a better term. But some people do call that a median of a trapezoid. And so when we are talking about the median of a triangle, we are not connecting the midpoints. We are connecting the vertices to the opposite. And I got this pre-typed, so I don't have to write this. And so, because I wrote it before and it took forever. Remember, median of a triangle connects the vertex to, look at that, to the midpoint of the opposite side. And you're going to tell that it's going to go back to the handwritten version in this video, because I entered this in because it took me way too much time to write all that when I was watching it. So we're going to connect the vertex to the midpoint of the opposite side. And when we do that, these are the medians. And remember, there's a theorem on your homework. It's going to say what theorem? That in a right triangle, the length of this median is always half the length of the hypotenuse. So I told you an answer. Remember that, since Morgan's not here to tell us. But she really is here. So hi, Morgan. And then we go to the midpoint here. Okay? So those are the medians. And so you need to know that. And that's when it refers to opposite vertex to the midpoint of the opposite side. Now, a couple things to find the midpoint. Remember, if you had two ordered pairs x, y, the robots in the class, you had an ordered pair x, y, you had another ordered pair x, y. And the robots in the class would say, well, this is x1, y1, and this is x sub 2, y sub 2. And all the robots who just play scales when they play music and they never sing a song. Why would you find the midpoint? What would that be, Megan? Yes, it'd be x sub 1 plus x sub 2 divided by 2. And it'd be y sub 1 plus y sub 2 divided by 2. But who in the world needs a midpoint formula when all you're doing is averaging the x coordinates and you're averaging the y coordinates? So this midpoint is 3, 4. Plus I could just read it off my graph. This midpoint barely fits in the screen is 6, 2. I shouldn't do this when we're videotaping. Almost off the screen. And this midpoint is 3, 2. So you can either get them by the graph, which I drew graphs for you on your homework, or you can use that formula, or you can average the x coordinates and the y coordinates. But we want to find the distance of these. What is the length of this? Whoa, I really should hit the line. And so what's the length of this median? So we could label it. We could call this a point, x or whatever, and we could say, what's the length of ax? Remember, we could use the distance formula. And the old distance formula was something we never ever wanted to use. It was the difference in the x's squared plus the distance of the y's, the distance, the difference, the distance between the y's squared, and then you square root the whole thing because it's really the Pythagorean theorem. The distance formula in the back of our mind, we're not chained to some formula, is a squared plus b squared equals c squared. And so I never really wanted to use that formula, even though I used to. That's all I used to know. But if we call this ax, the length of this would be 2 squared plus 6 squared. And so ax 2 squared plus 6 squared, you can at least show a little work. 4 plus 36 is 40, and that's the square root of 40. But what does the square root of 40 simplify to, Avery? Yeah, 2 square root 10, 4 times 10. Don't forget that. The high school teachers need to know that I actually taught you something. What if we say this median right here, we could call it BY, by the way. And so what's the length of BY? Segment, measure of segment BY. And that one is 3 squared plus 4 squared. Do we need to do any more? Remember when we used to take quizzes? Mr. Nyson could quiz you over all the Pythagorean triples. You wish that this corona quarantine was happening then. You would never had to memorize your Pythagorean triples. But see, you're glad you know them. Because Tim, 3 squared plus 4 squared equals 5 squared. And so the answer to that is 5. Or the square root of this. Or the square root of this if I actually show good steps. Since we're on camera, we better show good steps. And then what's the length of C? Should we call it CZ? Because it's easy. And so CZ, the right triangle that makes that one is right here. And so 3 by 2. And so it's 3 squared plus 2 squared, which is square root 13. See, Carson? I skipped the step, but I trust you. So, square root 13. Okay? So those are your medians. And if asked to find them all, then find them all. Okay? So we're just jumping to the end ones and going to try to talk through these. So let's look at this next one here. I don't know where to put myself. We'll move this up. Just got a couple more. Using analytical geometry, and I'll put myself down here. Maybe make myself a little bigger so you can see me. Given points A, -1, 2, B, 3, 4. So here's A, -1, 2, B is 3, 4, and C is 4, -3. And sometimes, you know, it happens to all of us. We plot points wrong. And so we don't want that to happen. I don't know how I got sound on my face, but it's gone now. And so show that P4, -3 is on the perpendicular bisector of AB by using the distance formula to show that PA equals PB. Well, you don't really have to use a distance formula. You're just using the Pythagorean theorem. And so you don't need to use the distance formula. So here's AB, -1, 2, and 3, 4. And we're going to show that point P is on the perpendicular bisector of this. Well, if I took my compass and I found the perpendicular bisector, remember, by going from here and going arc and then going this way and going arc, arc, arc. Might think you're a penguin or what, a walrus? Arc, arc, arc. And so remember how to do that? But we don't really want to draw those. We're going to show analytically that it's on it. We used to show with a construction that it was on it. But now let's show analytically that's on. Well, if you're on the perpendicular bisector, you need the slope. And I first need the slope of AB. So in case you don't know which one's A and B, because we haven't labeled them yet, there's A and there's B. Well, the slope of AB is 1/2. So what would be the slope of the perpendicular? Slope of the perpendicular. Remember, that was the upside down capital T. The slope of the perpendicular would be what, Grant? Yes, the opposite reciprocal would be -2. And so if I'm here, and then I got my slope of -2. That's very good. So I know it's on a line that's perpendicular to it, but now how do I know it's on the perpendicular bisector? Well, you'd have to find the midpoint of AB. What is the midpoint of AB? How would we find the midpoint? Well, we could do x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. And I sound like a robot. And so we want to average the x's and average the y's. You can do this in your head. What's halfway between -1 and 3? If you don't know, you add them up and you divide it by 2. What's halfway between 2 and 4? If you don't know, you add them up and divide by 2. But I think everybody and their brother knows what's halfway between 2 and 4. It'd be 3. And what's halfway between -1 and 3? Oh, that'd be negative. Oh, that'd be positive 1. Yes. 2 away from negative 1 is 1. 2 away from 3 is 1. So that'd be the point 3. Is this my midpoint? Yes. And so all I want to know from you is that it is the perpendicular bisector. But guess what? I still didn't do what they said. Mr. Nyson, you don't read very well. How many AR points you got this quarter? It says by showing that PA is equal to PB. Oh, yeah, there was that theorem. Morgan, why didn't you tell me there was a theorem? That any point on a perpendicular bisector is equidistant from the endpoints of the segment. Ugh. Where's Morgan when you need her? Where is Morgan? Where is Morgan? Here I am. Here I am. I told you, Mr. Nyson, you weren't listening. You can't hear me. And so it has to be equidistant. So if it showed this, then we want to use where is my right triangle to show the distances. I showed it was on the perpendicular bisector, but I didn't use the theorem. If this is 5 by 5, what's this? 5, 5. Here, I use the distance formula. It's 5 square root 2. You've got to be kidding. I'm not using some formula for something I can do in my head. Then if we use this one, show the length of this one being the same. This would be 1 by 6. No. 1, 2, 3, 4, 5, 6, 7. That'd be 1 by 7. Well, what's 1 squared plus 7 squared? 49 plus 1 is 50. And what is the square root of 50? Sidel? Yes, 5 square root 2. It's the same thing. Woohoo! And I actually read the problem. Show that these are equal. And using my knowledge, and if Morgan would tell me the theorems, that any point on a perpendicular bisector is equidistant from the endpoints of the segment that it bisects. And so then we show that those are equal. Okay? Always pays to read. And so make sure that you do that. And then for the last one, let's take a look on this. It says, find the length of the shortest median of a triangle with vertices 0, 0, negative 4, 6, and 8, 4. And so since we're going to be in quadrant 1, I guess I'm fine sitting right here. So 0, 0 is going to be right there. Negative 4, 6, Mr. Nice, and that's not in quadrant 1, that's in quadrant 2. What are you thinking? Okay, quadrant 1 and 2. And then quadrant 1, we got 8, 4, which is going to be right there. Okay? And so let's make our triangle. Dun, da, da, da. And if it says find the length of the shortest median, well, you could find all the medians and see which one's shortest. Or you could try to just go for the shortest one right away. And so first thing is, here's a point, I need the middle. Well, if you just show the graph, here's the middle. And the middle of this side is negative 2, 3. Wasn't that nice? The middle of this side is right there, because that has a slope of 1/2, a slope of 4 over 8, 2 over 4, 1/2. And so the midpoint of this side is 4, 2. So on your homework, I made graphs. Just label them. Show me that you're kind of thinking through the process. And what's the midpoint of this side going to be? I think it's going to be length of the shortest median. Median is what? Do we just connect the midpoints? Is that medians? No. What's the median, Jack? It goes from the opposite vertex to that. So there's a median. Should I change colors? Would that be nice? Help keep you awake. There's a median. And here's a median. Oh, hopefully those are the colors. Which one do you think is the shortest? Well, we could label them. We could label this, since I never labeled the points. We could go A, B, C. And we could go X, Y, Z if you wanted to. And then labeling, notation is always important in math. And so we could just write AX is 2 squared by 5 squared. Well, that's square root 29. BY Remember, you got to see your right triangle. It's like Sokotoa. He sees right triangles everywhere. And see, that right triangle would be what? 4 by 8. And so remember, when one leg is double the other, boy, that was quite the equal sign. When one leg is double the other, Carson, yes, Mr. Nyson? It is the short leg times, yes, square root 5. Don't forget those things. Those are amazing things to know. And it's just like 4 square root 5. And then CZ, we could use the distance formula, but we'd still be on problem 1 if we were doing that. CZ is right here. It's 1 by what? 1 by 10? Kind of fast. 2, 4, 6, 8, 10. Well, that'd be square root 101. You know what the short leg, the shortcut is for when one leg is 10 times the other leg? Yeah, you take the short leg times the square root of 101. Now, which one of these is the smallest? Well, maybe you'd have to type it in your calculator. Well, square root 29, or maybe we shouldn't have simplified this. Square root 29, I don't need to type it in my calculator. Is the square root of 101 or the square root of 29 smaller? I believe it'd be the square root of 29. And before this was simplified, 16 times 5, that'd be 80. Square root of 80 or square root of 29? I believe it would be the square root of 29. And so there's my shortest one. So make sure you let me know which one's the shortest one, because you might not know. Okay? So on your homework tonight, on the last assignment, when I tried to make, whoa, I brought that back. We don't want that back. When I tried to make it easy on you, sometimes I make mistypes and things, but 14, 15, 16, notice I left out the bottom 2 quadrants on 17, 19 to give you a little space to write. On 20 and 21 and 24, I give you more space to write. And so you want to make sure that you're getting everything. And so if there's one you want me to do, I'll do it with you. And so all you have to do is ask. And so which one would you like for me to do? Which one do you think looks the hardest? 24? 24 is not hard. It says if the ratio of the 2 points, here, wait, I think I got a copy of the homework. Whoa, look at that. Which one do you think would be the hardest? 24, look at the 24. How far apart are 2 and 7? 5. And look, 2 plus 3 is 5. And so if you want to know the point, you don't even have to graph this thing out. But I made a graph, so you should use it. But how far apart are 1 and 11? 10. That just happens to be 5 times 2. So your fraction would be 4 to 6. That's not that tough. And it's a C problem. And that was about a 2-second one. And so what about problem 21? You could graph this. It says find the coordinates of the midpoints. And so graph it and then tell me what K is and L is and M is and J is. And what type of parallelogram is it? So if it looks like just a parallel, what type of parallelogram? I already told you, but maybe it's a special type. If you're going to prove that it's a parallelogram, you just prove that the opposite slopes are equal. If you prove that a rectangle, you'd prove that the opposite slopes are perpendicular. If you're going to prove that it's a rhombus, you could prove that it's a parallelogram and the sides are congruent, so you could show me what the sides are. Or you could show that the diagonals are perpendicular. With opposite slopes. So there's a couple ways. And so on some of these problems, it says like on 20, maybe I'll move myself over here. It says, show that using the distance formula that DE is 1/2 BC, so graph it. And your ABC, I give you space. 19, state a theorem from chapter 5 suggested by this exercise. You don't really need to know what chapter it's from. It's not 5-whatever, although you could look in the back of the book. But you need to just remember your theorems. What's true? If this is equal to this, which is equal to this, which they all are, then what's said they're all equal? And I'd say right triangle. Okay? And so on well, you really should have given the hints in order. It's kind of like backwards day here. But problem 14 is the first one you're going to do. How do you show that a triangle is isosceles? Well, it has two congruent sides. So graph it and label the two congruent sides. Altitude means the height. Find the coordinates. Find the midpoints of the legs. Find the lengths of the median. That's to the opposite vertex. Find the length of the longest median. Verify the midpoint. So label the midpoint. Actually label what it is. Okay? And so you got this. And so you guys are doing a great job. It's hard to believe that there's only 2 more Fridays after this. And at the end of our 3 years together. And so it's went really fast, and who would have thought that it would be kind of coming to a conclusion like this. And so remember, Kermit the Frog always says, time's fun when you're having flies. And so I hope all of you have a great Friday. We miss all of you a lot, and we wish we could be there and just teach in class without having to record all these things. And so just, you guys are all doing a great job. And so you know a ton of math, and I don't think you can even believe to know how well you guys are doing. And so keep up the great work, and email me your questions, and don't wait till 1 a.m. I know who you are. And it's like, what are you doing? The sun's shining. Get working. And so, hey, we'll see you guys. Bye-bye.